On the write down the next heading was Ampere's circular law. So what is Ampere's circular law status? If you have a current carrying conductor, okay, then if you have a point P where you are supposed to calculate the field, then around this current carrying conductor, you can consider a symmetric surface, which is called as an Amperian loop, okay, in such a way that the surface integral of B vector dot dl vector, actually it is not surface integral, it is called as line integral. So the line integral of B vector dot dl vector, 1 minute, will be equal to mu naught times the total current that is flowing through the, the total current that is enclosed by the Amperian loop. So surface integral of B vector dot dl vector is equal to mu naught times I net is the total current enclosed by the Amperian loop. Okay. I'll tell you the steps that we are supposed to follow. Okay. The thing is, when you consider, so let's say, application of Ampere's circular law, and if I take the first one like this, if I take a straight current carrying conductor in this way, where this is of infinite length, okay, where I have a conductor of infinite length, and the current is flowing in the upward direction, let's say it is I. If I take a point P here, which is at a distance A from it, okay, then I know that the magnetic field at point P is going to be equal to mu naught I divided by 2 pi into A. Okay. So when that is a scenario, I will take an Amperian loop like this. Okay. So on this Amperian loop, so it is something similar to Gauss law only. On the Amperian loop, I'll consider a small element dl and give direction to it in this way. Okay. So this dl is actually into the plane. Are you able to understand? So when you have a current carrying conductor, Amperian loop is like this, dl is into the plane. So there is a direction of current, there is a direction of dl. Okay. So when it is into the plane, then I can write the line integral of B vector dot dl vector is equal to mu naught times the total current enclosed by the Amperian loop. Okay. So line integral of B into dl into cos 0 degrees is equal to, because magnetic field is also into the plane, dl is also into the plane, is equal to mu naught times the current enclosed by the Amperian loop is I, because there is only one current carrying conductor. So if I take that B outside, B into line integral of dl is equal to mu naught into I. So B into what is the line integral of dl? It will be 2 pi into A, because it is a circumference of that Amperian loop, is equal to mu naught times I, which implies B will be equal to mu naught I divided by 2 pi into A. Okay. This is going to be the value for the magnetic field due to a straight current carrying conductor of infinite length. Okay. Now we'll see.
So why are we taking DL on the Ampere?
You should, no, you should take it on the current carrying conductor. If you take DL, you will apply Bayes circuit. On the Amperian, if you take, you will apply Ampere circuit. Like it's similar to Gauss law only. On Gauss law, where do you take dA? On the Gaussian surface. On the Gaussian surface. Similarly, dl is taken on the Amperian loop. Okay. So next is magnetic field due to a long solenoid. So here, long literally means infinite length. Okay. So magnetic field due to a long solenoid is what we are going to see now. So when I take a solenoid, if I take a rod like this for matter, for instance, and around this rod, if you have a wire that is wound like this, okay, and let's say the current across the conductor is flowing like this. Now, I is into the plane. Okay, at the top it is into the plane, and at the bottom it is out of the plane. What is it? It is the direction of current. So the direction of current is into the plane at the top and out of the plane at the bottom. Okay. So for this, what we will do is we will draw an Amperian loop and then try to derive the magnetic field at the center of it. So remember, as I told you, it is a long solenoid. Long in the sense, generally, when I say long, it is of infinite length, we can say, or we can say it like this. Length is more compared to the thickness. Length is more compared to the thickness. Even that you call it as a long solenoid. Is that clear? Now, when this is the scenario, listen. When I have a cylinder projected on a paper, it looks in the form of a rectangle. So cylinder is three-dimensional. Cylinders projection on paper gives rectangle. Correct? Now, when you take a line like this in such a way that the current at the top is into the plane and the current at the bottom is out of the plane. Is it right? So current at the top is into the plane and the current at the bottom is out of the plane. When this is the scenario, then we will consider an Amperian loop in such a way that half of the rectangular portion is out of the plane and half is into the plane. Okay. Now, if I take this distance to be A and this total distance to be B, is it clear? So if I take it to B, then I'm saying B by 2 is outside and B by 2 is inside. The remaining half is inside. Right? Now, if I look at the formula, then the surface integral of B dot dl, okay, from A to B plus the surface integral of B vector dot dl vector. So it is B vector dot dl vector from B to C plus the surface integral of B vector dot dl vector from C to D plus the surface integral of B vector dot dl vector from D to A. The sum of all these values should be equal to mu naught times the total current that is flowing through the circuit, or total current enclosed by the Amperian. Can I say that? Right? So, if I look at the magnetic field outside, right, for a long solenoid, generally what happens is magnetic field outside is 0 and magnetic field inside is a constant. Magnetic field outside is 0 and the magnetic field inside is constant. Okay. So when outside is 0, then the line integral of B vector dot dl vector from A to B should be a 0. Okay. And the line integral of B vector dot dl vector from B to C is also a 0 because, listen to this carefully. So what happens is the magnetic field inside will exist from right to left. Why is it so? Because if this is the solenoid, if you take this to be the current carrying factor, this is the direction of current. When you curl your fingers, inside it is coming in this direction. So this is the direction of magnetic field. When you take that to be the direction of magnetic field, in the case of B to C, right, magnetic field and length are perpendicular to each other. So B dot dl is 0. Similarly, the line integral of B dot dl from C to D exists. It's a non-zero value. And the line integral of B vector dot dl vector from D to A is also a 0 because B vector and dl vector are perpendicular to each other. Okay, when that is the scenario, then the line integral of B vector dot dl vector from C to D is equal to mu naught into I net. Am I clear till this point? A to B input. That's not limit actually. You are saying that from A to B. You can write AB or A to B if they are not, it is the same thing. Doesn't make a big difference. Okay. Okay. Now see the line integral of B into dl into cos 0 degrees will be equal to mu naught into what is the net current that is flowing through the circuit. This is what we need to find, I net. Okay, let me call this as equation number 1. Listen to this. Let capital N be the number of turns in the solenoid and small n be number of turns per unit length of solenoid. Okay. So small n will be equal to capital N divided by L. Correct? Small n will be equal to capital N divided by L. Okay. Now, if I say n dash is equal to number of turns between the points C and D. Okay. So n dash be the number of turns between C and D, and L dash be the length of CD. Is it clear? So when that is the scenario, then n dash will be equal to small n into L dash. Correct? Is it right? N dash will be equal to small n into L dash. Okay. So line integral of B into dl is equal to mu naught into I net regular. So in the place of I net, can I write n dash turns into I? Because if I is the current through one loop, there are 1, 2, 3, 4. For example, this diagram has 4 loops. There can be n dash loops that are existing between the size of the Amperian loop that we consider. So n dash, can I write it as small n into L dash? Right. So when I do that, B, if I take it out, B into the line integral of dl will be equal to mu naught into n dash into I. So B into what is the value of line integral of dl? It will be L dash. Yeah. Because the line integral of dl, where are you doing it from? Line integral of dl, you're doing it from C to D. But what is the length of CD? The C to D. Yes. So it is L dash is equal to mu naught into n dash into I. So B will be equal to mu naught into n dash divided by L dash into I. But what is n dash divided by L dash? Small n into I. So this is going to be the expression for magnetic field due to a solenoid at its center. So this is the value of magnetic field due to a solenoid at its center. Okay, make a note of this. Done. So the last application that is left out in this chapter is magnetic field due to a toroid. And the last one is TOROID. So it is a circular solenoid. Okay, it is a circular solenoid in the sense when you take a solenoid and bend it exactly in the form of a circle. Okay, imagine solenoid will be like a rectangle. Beautiful solenoid. This is how a solenoid looks like. If you take this and bend it to the form of a circle, then how will it look like? It look like a circle. It will basically look like a donut. Okay, around which you have the wiring happening. Okay, again here also you have current into the plane at the top. Means when you see it like this, right? The winding is there, no winding. At the top, the current is into the plane, and at the bottom, it is out of the plane. Are you able to understand this? So this has, let's say, a radius A, and this has a radius B, and the inner radius, let us call it as R. So the thickness is going to be very, very small because it's a long solenoid generally bent in the form of a circle. Okay. So what happens here is we will calculate the magnetic field outside. Okay. We'll calculate it between and we'll calculate it inside. So magnetic field, if you take it outside, it is a 0 again. Same logic because you're taking that long solenoid and bending it, right? Similarly, if you take it inside, what will happen? That will also be 0 because inside means this portion, guys. Listen. Inside this portion. Inside is like out of that cylindrical portion. So this is the part that is getting bent. So with respect to this is also outside, this is also outside. But when you bend it in a circular form, the upper part will become outside, but the inner part will become inside. But still, here also the magnetic field is going to be 0. So where is the only place where magnetic field will exist? Only between. So for between, you can consider an Amperian loop which is symmetrical with respect to this structure. Okay. So when you take a symmetrical structure, right? Now you'll take a DL here. So DL will be in this direction. So line integral of B vector dot DL vector is equal to mu naught into I net. So let's say total number of turns is equal to N. Okay, well, then N, can I write it as small n into 2 pi r? Can I write it? N and small n, generally in physics, where do we use it? Number per unit length. So small n is capital N divided by 2 pi r. 2 pi r is the radius of that toroid loop. Okay. So the surface integral of B into DL into cos 0 degrees will be equal to mu naught into what is the value of current, total current that is flowing through the circuit? N into I. Correct? So due to one loop, if the current is I, due to N loops, it is going to be N into I. So the line integral of d, I'll take it out. Line integral of dl is equal to mu naught into ni. This implies b into what is the line integral of dl? 2 pi r. You know, the dl Amperian loop is covering the whole circle. So it's covering the whole circle. So 2 pi r will be equal to mu naught into capital N into I. So b என்னவா இருக்கும்? Mu naught into capital N divided by 2 pi r into I. So answer will be mu naught into N into I. So the magnetic field inside a toroid is also mu naught into small n into I.
R வந்து சென்டர்ல இருந்தா அந்த
Average. Clear? Okay. So that's all with this chapter. We are done. Okay. Now next thing is problems. We have covered almost everything. I gave you an assignment yesterday. Did you solve it? You finished
Some
it?
questions I added on. So
Okay. I want to see it by tomorrow. How much ever you have completed, I want to see it. So what are the doubts you have? So we can try out some problems that are based on this concept of voltmeter that we discussed in the previous class. Let's try them out. So voltmeter has a range V. So question number 6. What resistance should be connected in series with it to increase its range to NV? So voltmeter has 1 minute. Hello. Later. Class has not started. It has been going on. No? Which link did you join? One minute, wait. Oh, sorry. 1 minute, ma. Join this link. No? Yeah. See, next time, no, please check the time. Actually, there has been a confusion. It is 5 p.m.'s link. Okay. It is 7 p.m. Yeah. Yeah, you can see it. Yeah. Okay. Okay. So voltmeter has a range capital V. Okay. What resistance should be connected in series with it to increase the range to NV? Okay. So how to solve this? A voltmeter has a range V. What resistance should be connected in series with it to increase its range to NV? So you have a voltmeter. Okay, I'll give you a simple problem, which is a direct application of formula. Start with 17. So look at this problem. If only 2% of the current is to pass through the galvanometer of resistance capital G, then the resistance of the shunt will be how much? If only 2% of the current is to pass through a galvanometer of resistance capital G, then the resistance of the shunt will be. Try it out. You have a formula, right, already?
So is it 49G?
No. Check your calculation.
So then should it be 50G because the shunt resistance and the actual resistance should be in series and only 2% pass through, meaning that it should be 50.
No. See, you're getting confused. Shunt itself means parallel, okay? You cannot say shunt resistance will be in series. That is wrong. So when you convert a galvanometer to an ammeter, you should always connect a shunt resistance in parallel. So this is a formula. R shunt is equal to Ig into G divided by I minus Ig. Last class I discussed.
Yes.
Yeah. So Ig is how much? 2% of the total current flows into capital G divided by I minus 2 by 100 into I. Okay. So how much will the answer be?
Uh,
Cancel.
G by 49.
Yes. G divided by 49 will be the answer. Okay. Next. Solve the 24th one.
So 3.
Yes. So resistance of galvanometer is 6 ohm. Maximum current it can measure is 2 ampere. Then the required shunt resistance R shunt is equal to Ig into capital G divided by I minus Ig. So Ig is 2 into 6 divided by 6 minus 2. So 2 into 6 divided by 4, it is going to be 3. Just 3 ohm. Now try out 25th problem.
N minus 1G.
That's right. So keep proceeding. A voltmeter has a resistance of G ohm and range of V volt. The value of resistance used in series to convert it into a voltmeter of range NV. So how to do this?
So it will be connected in series. Before it was G, now it is NG, meaning
So
that
before it, V is equal to how much? Ig into
RG plus R.
Rg plus R series. Correct? So R series will be equal to V divided by, okay. Can I say Ig is equal to V divided by G? V is equal to IR. Ij will be equal to V divided by G. Take this and substitute it here. Okay. Okay, not there. 1 minute. So if you read the question carefully, they are asking the new voltage is supposed to be NV. So NV is equal to Ig into G plus S or RS. Okay. So NV is equal to Ig is how much? V divided by capital G into G plus RS. So NV into G divided by V is equal to G plus RS. V and V will get cancelled, which implies RS is equal to N minus 1 into capital G.
So why should we do this much? Can't we just directly say previously it would be N, now it actually it would be N as such, and now it should be N into N minus. So why can't we do that?
Why will it be N minus 1? Because it is not exactly the same resistance that you are going to connect. No, this value will change. No.
So previously it was 1, now it is changing to N, meaning that 1 should get 1 should be replaced by
Okay,
N.
but that's fine. When you try to solve it, right? What would have happened here? This value of RS, see, when you write it initially, V is equal to Ig into G plus S. What are all the constants here?
G will be constant.
Ig is constant, G is constant, but RS in the first scenario and second scenario are changing. No? Unless you know this value, how can you say they are in proportion? That's my question.
So because previously I took V is equal to 1. Now I'm previously I took it as 1. Now I'm taking it as NV.
See, the value of resistance used in series to convert it into a volt. So it is the same galvanometer. Correct?
Yes, sir.
I am able to understand what you're saying, but how will you say that RS, what proportion it would have changed? That is what I'm concerned about.
So I took it 1 plus N minus 1 will be equal to N. Previously it was V, now it gets us NV, so it will be right.
1 plus N minus 1 is V.
1 plus N minus 1 is equal to N.
Okay.
Previously it was just 1. Previously it was just 1V, now it is NV.
But Mike, see, you're using logic is right. That is for competitive exams. Your logic is, I'll come again. Wait, listen. So did you read the question carefully? What are they saying? So initially, a voltmeter has a resistance of G ohm and range of V volt. But how did I take that IG to be V divided by G? You never asked me that question. They told it's a voltmeter.
V is equal to IR.
Okay, then what did you take V is equal to? V is equal to what? IG into?
IG into RS, RG plus RS.
Correct. You took resistance of galvanometer plus resistance of series. Okay. But my question is, you don't know what is the value of resistor you connected in series in the first place. And read the question again. They gave you G only to confuse you. They are saying voltmeter has a resistance G means this RG plus RS totally put together is G. It is not the resistance of the galvanometer. Please understand that. Because when you look at the circuit, right, it is G and this is RS.
Oh, okay, sir.
You are able to understand. You escaped in this problem because they use the word voltmeter. Had they used the word galvanometer, you would have got stuck because they are not in proportion. Unless I know what is the value of initial RS that was connected for me to measure V volts. You're able to understand what I'm trying to say?
Yes, sir.
Yeah. So read it. Here it is voltmeter means it is the equivalent resistance of both galvanometer and resistor in series put together. This resistance is what is G.
G.
So that's what you need to spend. That is the reason I showed all those calculations. So finally, what they're saying, I want my voltmeter to measure N times V. For example, initially the voltmeter was measuring 5 volt. Let's say I want to increase it to 20 volt, which is 4 times the initial value. Then using the same galvanometer, what changes do I need to do? Then IG would have been V divided by G, where this G is the resistance of the voltmeter, not the galvanometer. Have that in mind. Into the resistance of galvanometer but unfortunately we had to take it like that here. So resistance of initial voltmeter means I'm adding an additional resistance here, RS dash. Are you able to understand it? That G plus RS dash. What is this? RS dash is what they're asking.
So I think it's the same logic, sir. Over there,
logic is right. Logic is right. But you have to show the steps, no?
Okay, sir.
So I have to see, if suppose you want to do this practically, what will you do? Suppose I give you a galvanometer, I'm saying connect a resistor in series means, if you connect this value and leave it, things will change.
So previously I considered RS as 0. Now in this case, I consider it as N minus.
Yes, you should not take it as 0 because by connecting that RS, only that galvanometer got converted to voltmeter. Don't forget that. Okay, so practically things will not work.
Okay.
Yeah. 26th.
One by 490.
Sir, 1 by 500.
1 by 500 or G by 500?
1 by 499.
1 by
500.
Read the question carefully.
Sir, is it option D?
Option D is right. Mitra, you got resistance of galvanometer, not the ammeter.
Oh, okay, sir. I got only for the initial one. I didn't add the other one.
Yes, you got the resistance of shunt.
Yes, sir.
Right. So, in an ammeter, 0.2% of the main current passes through the galvanometer. So, when you look at the galvanometer diagram and shunt resistance, out of 1 I ampere or whatever you call it, 0.2 I is flowing through this and And how much is passing through this? How much is passing through this? 0.2. இதுல 0.2 I divided by 100 flow ஆகுதுன்னா 100 minus 0.2 எவ்வளோ? So 99.8 I divided by 100 is flowing through the remaining portion. அப்ப என்ன பண்ணும்? R shunt will be equal to how much? Ig into capital G divided by I minus Ig. When you calculate it, you will get the value as G divided by 499. You can do that and see. Okay. So G divided by 499 is this value. But they are asking the resistance of the ammeter. So how is the galvanometer and shunt resistance connected? Obviously, they are in parallel. Appo enna pannum? R1, R2 divided by R1 plus R2. So you will get G square divided by 499 divided by 500 G divided by 499. Cancel them. Cancel G. You will get G divided by 500. Breathe. This is how it works. Okay. 31st. To convert a galvanometer into an ammeter, a small resistance is connected in parallel with it. Is it right?
Yes, sir.
It is true. So here two important points. Parallel with it and small resistance. Both are true. The resistance increases the combined resistance of the combination. So the small resistance increases the combined resistance of it is false because when you connect something in parallel,
It decreases.
Decrease. That's how it works. So 32. Out of galvanometer, ammeter, and voltmeter, the resistance of ammeter is the lowest and the resistance of the voltmeter is the highest. Correct, Adha?
Yes.
Yes.
So that is
True.
true. An ammeter is connected in series and voltmeter is connected in parallel in a circuit. Yeah?
Parallel and volt.
There.
Oh, to a circuit.
Ammeter than a series because series the current is the same. That is also true.
But the resistance.
No. So both are true. Now is the assertion the right explanation? Reason the right explanation for assertion?
Yes, sir.
This is slightly ambiguous. Okay. The slightly ambiguous. It can there will be different contradiction taking place. According to me, both A and R are true, but R is not a correct explanation. I'll tell you the reason why. An ammeter is connected in series only to ensure that the current in series is same. And voltmeter is connected in parallel because in parallel, current is same. But that doesn't mean the ammeter's resistance is just because you connect an ammeter in series with a circuit. Just because you connect an ammeter in series with a circuit, you cannot say it has less resistance. It has less resistance because across a galvanometer, you connect a shunt resistance in parallel. So it has nothing to do with series and parallel. So independently, both the statements are true. But why the resistance of ammeter is less is not the right explanation. Okay, so answer is D. Okay. Next is, that's it. So these are all the problems that are based on galvanometer. So remaining problems, I want you all to try and upload your assignment by today. Okay, I'm very serious about it. Upload it. I've given warning for the previous batch also. I have only one assignment submitted out of 38 members. So I want you all to see, submit the assignment. If not, I'll not let you in tomorrow for tomorrow's class. How much ever you have
Sir,
solved
just
up.
the answers.
With details, I want with solutions. I don't want only the answers. Just marking A1 is 2 to other. I want detailed solution even if your answer is wrong. Okay.
So can you do the 14th questions?
A deuteron of kinetic energy 50 kiloelectron volt is describing a circular orbit of radius 0.5 meter in a plane perpendicular to the magnetic field.
What is it?
Deuteron is H21. H21. Proton, deuteron. Deuterium, if you remove an electron, you call it as deuteron. Now you try. You have isotopes of hydrogen, right? So from the isotopes of hydrogen, the second isotope, that is deuterium, if you remove one electron, you call it as a deuteron. Resistance of galvanometer. G is galvanometer. That's for resistance. Galvanometer has a resistance Rg. Ig into G plus R. Okay. So this part, since you know the concept, you can try it at home. Any other doubt that you have since you told you solved till 31st?
So 24. What?
24th, I already told. We solved it today. Yeah. That's it. Huh? Okay. So try the remaining problems also and try to upload them. Okay, I'll check them.
Sir,
Tell me.
sir, there's an exam in school tomorrow, sir. Can I upload it tomorrow?
Hey, how much have you completed?
I completed only the first 10, sir.
Okay, whatever you have completed first upload.
Okay, sir.
Okay. Fifth one. Proton and alpha particle enters. There is a proton and an alpha particle. So proton, if its mass is empty, alpha particle's mass is 4 times empty. If proton's charge is Q, alpha particle's charge is 2Q. This point is to be remembered. Enters uniform magnetic field perpendicular to the y-axis with the same speed. If a proton takes 25 microseconds to make 5 revolutions, then the time period of alpha particle would be. First time period for 2 pi m divided by q. You have this, no? Either use pannala. So it is entering with the same speed. Okay. If a proton takes 25 microseconds to complete 5 revolutions, then what is the time period of it? Time period is 5 microseconds. Yeah. 5 revolutions it took 25 seconds. For 1 revolution, it will take 25 by 5. So another 5 microseconds. So T1 divided by T2 is equal to 2 pi M1 divided by Q1 B1 divided by 2 pi M2 divided by Q2 B2. Correct? 2 pi are gone. B1 and B2 are the same because it's the same magnetic field. So Q2 divided by Q2B into M1 divided by M2. T1 is how much? 5 microsecond. T2 is what you need to calculate. Q2 is how much? Q2 and the alpha particle. 2 divided by 1 into m1 வந்து 1 by 4. So this goes 2 times. So 5 microsecond divided by T2. T2 வந்து 10 microsecond is the answer.
Sir, அப்ப அது கண்டிஷனா சார் புரோட்டானுக்கு வந்து MP
That is how they are defined. So which question is that? If the 10 microsecond is
25 seconds.
that's frequency.
சார் ஆனா ஆல்பா பார்ட்டிகல் புரோட்டானும் பிளஸ் சைன்
Alpha particle is helium 2 plus 1. Rutherford experiment use பண்ணுவாங்க இல்லையா? Helium 2 plus. So the scattering will take place. So இங்க 4 tune இருக்கும் அவ்வளவுதான். That is the meaning. So that is why it is 4 times the mass of proton, 2 times the charge of proton. So this is proton, alpha particle are commonly used terms in magnetic effects of current. Now, if you see most of the questions, they would have been on that time. And radius of the circular orbit. Be very careful with that. Otherwise, problems.
இன்னொரு क्वेश्चन நீங்க வந்து வெறும் டயாமீட்டர் 0.1 நானோமீட்டர்
Find the angular speed. The fourth one.
அது வந்து
Electrostatic force yarda. V வந்து r omega. It is mr square omega. அவ்வளவுதான். Sorry, mr omega square. mr square omega. mr omega square.
equal to r.
V is equal to r omega for circular motion. So if the electrostatic force on the, so this basically there is a proton here and an electron which is revolving. If you know the distance, k q1 q2 divided by r square put calculated. Okay, so here it is combination of first it is more of either. Magnetic field, they would have given the unit as 14 Weber per meter square. WB na Weber. Weber is a unit of flux. Weber per meter square is Tesla. Weber is actually unit of magnetic flux. So yeah. So that you will see it in 6th chapter. So Weber per meter square is Tesla. Like how you have electric field in Newton per coulomb that you would have seen in 1st chapter, 2nd chapter la volt per meter இருக்கும். ஏன்னா it comes from potential gradient. அதே மாதிரி you can write the magnetic field in terms of flux as well. So how you write magnetic flux as B into area. So B is Tesla, area is meter square, Tesla into meter square is Weber. அப்ப இந்த meter square இப்படி வந்தா என்ன ஆகும்? Tesla. So another they gave it like that. Okay. Clear? So we'll wind up. Upload how much ever you have completed. Okay. I'll see you all. Sri Mitra and Ritika.
Yes, thank you.